Okay, so let's imagine these two squares are these lengths too, and we have arranged them as in the procedure states. We have put heptanol in the left one and methanol in the right one, and we have applied the vacuum to both of them. They are both in the same conditions, but methanol shows a higher pressure than heptanol. Why is that? Well, that's what we will. Well, the kinetic theory of matter states that elements or substances are gas, solid, or liquid dependent on the vibration of the molecules. If, for example, the molecules vibrate really slowly and have a low wide vibration, they will be solid. If they vibrate really fast and they move in a wide range, they will be gas. The middle term between them, which will be a slower vibration than in gases, but higher than in solid, will be water. In here, both heptanol and methanol are liquid state. But as heptanol has a bigger molecules than methanol, as we can see in these drawings, heptanol will also have high intermolecular forces, as their molecules are big and hold on to each other more strongly, as we can see in here. Let's imagine that all of these ones do the same too. While in the methanol molecule, their van der Waals forces are much weaker, as we can see in here, meaning that they will need more kinetic energy to jump into a gaseous state. Substances always want to get into a gas state, either because of heat or because of a low pressure, which is the case of this one. They all want to reach the pressure equilibrium, in which the pressure in the air is higher enough to keep the other substance in a liquid state. As we have applied the vacuum, the pressure in these places will be very low, meaning that both of the liquids want to become in gaseous state. But as the heptanol molecules have strong intermolecular forces, they will need much more energy than the methanol molecules to go into a gaseous state, meaning that even though both of them can have the same energy to go into a gaseous state, mostly the methanol ones will be able to do so as their bonds are really weak and can break easily, meaning that the methanol molecules will be able to go into gaseous state, which means that they will vibrate more and have a wider range of vibration. They will move more. While heptanol molecules will find it really hard to reach the gaseous state. This means that as heptanol molecules have very high intermolecular forces, they need less vapor pressure to reach pressure equilibrium and stay stable. While as methanol has lower intermolecular forces, they need more molecules in the air to reach this pressure in the air, which will make the liquid come stable. So the point of this is reaching a pressure that will keep the liquid remaining still. As we know, heat and temperature determine the state in which we will find these substances. And as the heat is the same for both of them, the pressure will be in charge of defining this. In heptanol, we will need less pressure to exert pressure in the substances, which will be the liquid, in order for it to don't become a gaseous state. Meaning that the heptanol pressure will be lower, but the methanol will be higher, because we will need a higher pressure in the air of this length tube to keep the methanol remaining in a liquid state. So we can conclude that the intermolecular forces between the heptanol molecules and the methanol ones are the ones that define the pressure we will find in the end of both of them.